afternoon, everyone. I'm Joy from Trend Micro, and I've been in the industry for 5 years. I'm currently working with ML operations on how to address web threats. And before I start this presentation, I'm going to turn off my webcam now. I want to introduce to you to two people. So to the left here, this is Michael. He's a designer or architect, and his job is to design the good place, a safe and secure place. And to the right, this is Janet, which is Michael's assistant. We're going to learn about Janet a little bit later. So if we're going to look at the current web infrastructure as a place, we would want it to be a good place, a safe, secure place. So as the world is becoming hyper-connected, with everyday objects connecting to the internet to send and receive data. So according to a report from IBM, 2.5 quintillion bytes of data is being generated each day. And although technological innovations are becoming fast-paced, threats and risks to information in devices and systems are also adapting. So threat data is no exception to the presence of big data. In fact, in the past year, 2020, Trend was able to block 62 billion threats. So we can say that everything is fine, right? Since there's a lot of threats being blocked. Actually, no, it's not fine because there's an increased complexity amongst threats. Criminals would add to its abundance as they continuously tweak up their game by tweaking old threats and creating new ones to evade detection. So if we have this generation of threats, having a pipeline of only analysis and solution using human expertise, it would not be able to keep up. So to address this vast amounts of threat data, security providers turn to machine learning to automate processes and improve security solutions. So the summary here is that with the great diversity and volume of threat data available, we can use machine learning to efficiently go through a data set, learn from it, and help reinforce defenses against cyber threats. I want to emphasize here the importance of value creation from big data. We can make use of this via machine learning. So remember Janet, the one I introduced earlier? Well, Janet, being Michael's assistant, contains all the knowledge the universe has to offer. Janet also adapts new skills and gets smarter every time she is rebooted. Well, similarly, AI and ML solutions becomes more sophisticated over time as we train it better, pass on better data, as well as features. Now we're going to look into the blending of old and new techniques used by threat actors to propagate their phishing agenda. So first one, it's an old phish technique, which is typo squatting. The threat actor would intentionally register domains with slight variations on existing web address to pick up traffic of misspelled URLs due to human error. And then in 2019, there was a rise in phish URLs wherein the arrival vector of them would be via email. So we would call it PDF phish. And the thing about this is that inside the PDF file would be a phishing URL link. So last year we have observed through our also analysis, an arrival vector was increasingly utilized, which is cloud services. So commonly used sharing services such as OneDrive, SharePoint, AppBox, and SendGrid are used to propagate malicious intent and phish URLs. So one will receive a link for the PDF file that deceives the user in downloading it or opening it, only to be infected when the URL is clicked. So further complications would include phishing redirection. So as I say, it's complicated since there are lots of redirection and if we can see it in manual analysis, what more if there's a presence of abundance of URLs. So that's why we would want to innovate the way we process things, and we can make use of that with machine learning. The last technique shown here would be with regards to Ryuk ransomware, to which it targets high-value targets, and it's been responsible for a third of ransomware attacks in 2020. So from before, the technique would be there's an Phish email that directs to a Phish page. Once the link is clicked, now this ransomware was able to evolve its technique by there's a Phish email, and then there's a link for this one. Example would be Google Docs was used that downloads a Trojan, and the Trojan here would be Bazaar Loader, and the Bazaar Loader would be the one to download the ransomware. So now, as threat experts, we know the methods cyber criminals use. Let's place ourselves to Michael, the designer. And how can we get features to model the ML model? So some of the features here can be taken from URL construction as well as content. So take note that we are not limited to these two. We can also check the metadata or example activities or the IP it resolves back to. So for the URL construction, we can check the length as a feature for the model. And then second one would be if the URL contains special features. Another feature can be possible specific keywords that Phish URLs target. Another one would be a URL within a URL. So what is the probability of having malicious redirection from URLs that contains another URL? So for the URL content, we use web scraping to extract data or source code from the website. So in this example, I think it has been shown that there's a strong indicator that most of the downloader URLs of malicious PDF file contains file extension in the title tag. And it's not a normal behavior for URL pages normally seen with legitimate web content. So we can then extract this tag as a possible feature that the model can process. And another challenge also would be malicious code can be hidden in web pages that are encoded via base64 or unescaped format. This is a challenge in the field as there's a need to decode it first and also presents a significant time burden. So while the use of features taken from human expertise is essential, there's still a blind spot or things as humans may miss out when creating features. So another application I can show you would be the use of natural language processing. So this is another type of ML technique wherein we use if the data being dealt with is text data and we want to get insights from it, may it be, for example, sentiment analysis or topic modeling, information extraction, etc. And the thing with NLP is that text data tends to be sparse, having hundreds and thousands of dimensions. So in order to apply ML techniques to NLP problems, we need to convert unstructured text to structured format for the model to understand. Okay, now for the application, I'm going to demonstrate the how topic modeling is used in analyzing COVID-19 URLs using latent direct allocation. So for this data set, 150,000 malicious URLs has been sourced, and our goal here as threat experts is to uncover patterns. So looking back in the recent pandemic, so there is a need in having to connect online through social media, news, government platforms for information, and also the use of cloud services. So for the social media platform, everyone would want to be informed. So fake news or stats that can lead to immediate action. one might not be able to check if the page is really legitimate. So threat actors have also latched to this opportunity of having to take immediate action to fake news or that. And there's a term coined by WHO, which is infodemic. In addition, work from home setup also led Phish URLs related to online video communication platforms, such as Zoom and MS Teams, for it to propagate. And lastly here, online learning classes. So last June 2020, there was a massive Phish campaign targeting the education industry in the UK. So students then were asked to fill out a health survey that also made them divulge their personal details. So for LDA, our input here would be the documenter matrix, and we use GenSim to go through the process of finding the best word distribution for each topic. And the output here would be the top words for each topic. There's also a visualization tool used, which is PyLDA-Vis. So upon initial checking of the data, you can notice how threat actors exploit cheap creation of URLs, or they may have a lookup that just appends random keywords to that. So the rationale for that is the more URLs threat actors deployed, the more chances someone accesses it. So if we feed this data to the model, it cannot understand it. So we need to pre-process it further. We can split it into characters or also into words. And it's also, there's a term called tokenization for that. Okay, now let's go to the insights. So here we can see the, for the subdomain. So the clusters formed here contained URLs with similar information, for example, only the keywords here, and can aid the threat experts in analyzing how threat actors were able to propagate their agenda. So in this cluster, we see keywords such as staging, dev, news, and media. So as you can see, this group of URLs here was able to group it with news outlets, media outlets. Next, what's interesting here is that the subdomain contains edu keyword. So this cluster, as I've said earlier, there's a Phish report regarding educational sites due to online learning brought about by the pandemic. Next set of insights, let's check the domain. Okay, so for this domain, this cluster has a bulk of URL containing Blogspot, Vaccine, and PhaaS. So as you can see, this group of URLs were malicious URLs that might be also aim is to provide where to buy face masks or vaccine updates. And then a specific cluster here in topic 9, there is a high term for Amazon AWS. So many domains here, malicious domains here, were hosted in AWS. And then for this cluster or topic cluster, there are terms such as map, protection, tracker, rapid tests. And map and tracker is what's notable in this cluster, since organizations have created dashboards to keep track of the spread of coronavirus to stay up to date with the latest information. So it also has been reported for the TrickBot malware to exploit it by having fake dashboards to steal information and credentials. So for this one, there is also cloud applications, Azure Edge, Strong, and email. So for this set of URL, Phish to an email platform via Azure Edge. So for the insights we got here, we got the auto generation of URLs. We also saw that websites in the subdomains use disguise as legitimate. And there's a prevalent use of sharing services, also as a way to avoid security product detection. Mhm. And so, as you can see a while ago, the LDA model has Janet have helped Mike. Janet here we can have Janet as a comparison for AI or ML tools have helped us, Michael's, the ones working in cybersecurity, to gain insight on the threat landscape brought upon the pandemic. So at a significant less time compared if we sift through these URLs. So this is one way on how ML can help gathering insight for threat intelligence that can aid in better protection of the web landscape. So what lies ahead for the future of the web threat landscape? So there will still be a reliance in cloud technology, and since the use of cloud technology greatly increased in 2020. A report from Forrester predicted that public cloud infrastructure will grow up to 35%. So with that, the use of cloud technology will still continue, and uh, the threats may become more complicated. Next would be there will still be targeted attacks in industries such as the government, banking, manufacturing, as well as healthcare. So it has been found that data sets were being sold in the underground that typically contain PII or personally identifiable information and user credentials from various cloud services. So moving forward, how can us security providers help? So the mention of current events for malicious attacks is nothing new for threat actors who, time and time again, would use the topics, occasion, as well as personalities in their social engineering tactics. Well, as you can see, people involved in protecting the cyberspace is just as important. When I showed you how we were able to analyze malicious URLs, and then the importance of them is that in defining the solutions by applying domain knowledge. Also, as you can see, these two people are looking at a map with many strings. So context-rich data or threat intelligence platform that correlates various data points is also important. So, and the last one would be collaboration among institutions, such as the conduct of this webinar, to enrich information is needed and is helpful in having a protected web. So us security providers are the Michaels, or the architects and designers that continue to provide solution to protect the web as a secure place. And Janet is an advancement, and AI or ML technologies that aids us. And I leave you with this artwork from Brennan Dawes called The Art of Cybersecurity. So the frame here is represented by the web or the internet, and the square obelisks like objects are the threats. So how you can see here the flow that represents the solution from security providers that is allowed to flow and neutralize these threats. Uh, Machine learning is only part of the solution and can greatly help addressing blind spots or dimensions human capacity cannot process. And there's a need for multi-layered defense to help address today's multifaceted threats. Thank you, everyone.